You're listening to Brains On, where we're serious about being curious.
There's just something about this sound. Flora, what do you think of this sound?
It makes me want to have fun at the beach.
I actually find this sound relaxing and soothing, it's like taking a big calming breath in and out.
Sure, but where do the waves that make this sound come from? And what about the tides? Is it true that they're controlled by the moon?
Those are great questions. And we'll get to them eventually. Right now, I think I'm just a little too relaxed to keep taping this episode.
Molly? Hang on, let me fix this. Is that better?
Oh yeah, I'm ready. We're going to answer those questions right now.
That's more like it. Keep listening.
You're listening to Brains On from NPR News and Southern California Public Radio. I'm Molly Bloom, and my co-host today is Flora Saldana from Los Angeles. Hello, Flora.
Hi, Molly.
This episode was sparked by a question that you sent to us.
How does the moon control the tides?
So what made you think of this question?
I was at a summer camp, and a girl said that the moon controlled the tides, and I wondered how that was possible.
So in Los Angeles, you don't live too far from the ocean. Do you like to play in the ocean?
I like jumping over the waves, and I like it when my dad picks me up, and we measure the waves by seeing how high it goes up on me, cause he picked me up so I'm taller.
Nice. So what do you think is the tallest wave you've ever seen?
When he was picking me up, it went all the way up to my shoulders once.
Whoa, that's crazy. And is it more fun to play with the wet sand or the dry sand?
When you're wet sand. When you're dry sand, because the dry sand will get stuck to you if you're wet.
And do you use the wet sand or the dry sand for your sandcastles?
The way I actually do my sandcastles is I just put sand on the bottom, then water, then sand, then water, then sand, then water.
That is a very good technique. It must be pretty strong.
Yep.
When I've built sandcastles in the past, they usually get swallowed up by the waves eventually because the tide is coming in. So let's get to that original question you sent to us. The moon does indeed control the tides.
Using
dun-da-da-da,
gravity.
All of this can be understood by looking at the universal law of gravitation, first postulated by the scientist Isaac Newton in the 1600s.
The gravitational force between two bodies is proportional to the mass of each body and inversely proportional to the square of the distance between their centers, and the force is directed along the line between the centers of the objects.
This means the gravitational pull between two objects is stronger the closer they are,
And the heavier they are.
The gravitational force of the moon is constantly pulling on the Earth. So what does that mean for the moon and the Earth?
It means the gravitational force between the moon and the Earth can be felt all over the Earth.
We don't notice the effect the moon's gravity has on land, since large land masses are solid and not easily moved.
But water is a different story.
Water moves easily, and the gravitational forces created by the moon cause water on the surface of the Earth to bulge. Sir Isaac Newton?
Yes?
Can you repeat the end of that universal law again?
Surely. The force is directed along the line between the centers of the objects.
So in the case of the moon and Earth, water moves to positions where all forces on it are balanced. This actually causes two bulges of water.
One is on the side of the Earth facing the moon.
The other is on the opposite side of the Earth from the moon. It's easy to wrap your mind around why water would bulge toward the moon on the side facing it, but why would it bulge on the opposite too?
Let's have our pal Isaac Newton explain.
Sir Isaac Newton?
Oh, of course. Sir Isaac Newton.
The strength of the force due to gravity depends on distance. So, over the volume of any extended mass of material, the strength of the gravitational force varies. It is this difference, called a force gradient, that is responsible for the motion of ocean water into the tidal bulges, okay? This force gradient is nearly the same size on the near and far sides of the Earth from the moon. And do you know how I was able to discover this very surprising result?
Lay it on us.
Calculus, a powerful tool of mathematics that I invented just to solve tricky problems like this.
Impressive, Sir Isaac.
Indubitably.
So calculate the force gradient.
Find out where these bulges are, and...
Ta-da! That's where high tide is.
That bulge keeps following the moon and moves around the planet as Earth rotates under it.
As the bulge moves around different parts of the Earth, so does high tide.
The sun also has gravitational pull over the Earth, but it's less than the moon. Even though the sun is much more massive than the moon, it's also much, much farther away. It's more than 90 million miles from Earth. That is so far that the gravitational force just isn't that powerful.
The moon, on the other hand, is about 250,000 miles away, not millions.
So its effects are much stronger on our planet.
But the sun does have an impact.
Like during the new moon, when the moon's completely dark,
The tides are more extreme.
high tides are higher and low tides are lower. This is because the weaker force of the sun is added to the stronger force of the moon.
And when this happens, when the sun and moon are lined up, it's called spring tide.
When the sun and the moon are at a right angle,
Like during half moon,
the solar tide partially cancels out the lunar tide, meaning the difference between high and low tide is smaller.
this is called the neap tide.
It's also important to remember that the Earth is not just covered in water. Different land masses create ocean basins.
So the motion of this bulge of water is affected by the continents.
Think about when you're in the bathtub. You move around a lot and the water sloshes from side to side.
When that water sloshes, you can see the water by the sides of the tub going up and down in height.
But there's a point in the middle where the height doesn't change at all. See for yourself next time you're in the tub.
The same thing happens in these ocean basins too.
These points where there are no high or low tide are called amphidromic points.
There are several around the world, including one near Perth, Australia, and one between Mexico and Hawaii.
There are also spots where the opposite is true, where their topography makes the difference between high and low tide more extreme than other areas.
The highest tides in the world can be found in the Bay of Fundy between Nova Scotia and New Brunswick.
In one part of this Canadian bay, the difference between high and low tide is 53 feet, or about 5 stories. This means boats on the wharf there end up sitting on dry land during low tide. Tides are caused by the gravitational force of the moon, and to a lesser extent, the sun.
But what about waves? Are these the same as tides?
We've gotten a lot of questions about waves, like this one from Riley.
Hi, my name is Riley, and I live in Boca Raton, Florida. And my question is, what keeps the ocean waves up until they crash onto the shore? Why are some ocean waves bigger than others?
Jessica Carilli is an oceanographer and a surfer. She is here to answer all of our wave questions.
Hello, Jessica.
Hello. Thank you so much for having me.
What causes waves?
Well, most of the waves in the world are caused by wind blowing across the ocean. Just like when you blow on a drink that you have and you can make little ripples, when the wind blows over the ocean, it creates waves. The stronger and the longer and the farther the wind blows over the ocean, the bigger the waves.
That's really cool.
Yeah. We can also get waves very rarely if a meteor strikes in the ocean or if there's an underwater landslide or an earthquake, and those waves are called tsunami.
Why are waves that shape? That sort of curving, crashing shape.
The shape of the waves is controlled very strongly by the shape of the bottom of the ocean. So when you're out in the deep part of the ocean and you go underwater, let's say you go 20 feet underwater or something, you tend to typically, you won't feel the waves. But when you're near the shore, when the ocean gets really shallow, that means that the energy of the waves starts to interact with the bottom. And it sort of drags in a way. It starts to slow down, but the top of the wave doesn't feel the bottom, and so it keeps going faster, and that is when a wave breaks, where the top of the wave is going faster and the bottom of the wave is dragging on the bottom, slowing down, and it crashes over in a sort of a barrel or a tube, as we like to call it when we go surfing.
Why are the waves so strong?
The strength of the wave is really related to how large the waves are, and the size of the waves is controlled by the strength of the wind. If you have a really big storm out at sea, you'll end up with really big waves. And when those waves travel across the ocean, they don't really lose very much energy. So in different places in the world or different times of the year, You can have really, really calm conditions, very, very small waves, or you can also have very, very large waves, just